graphing piecewise functions. We have f of x equal to -1, where x is less than or equal to -1, and f of x is equal to 1 when x is lying between -1 and +1. And third case, f of x is equal to x when x is greater than 1. That is, the function f of x is broken into three pieces. So on drawing the graph of this function over here, we are going to find three parts. Okay, so let us look at them piecewise, one at a time. We have the first case is f of x is equal to -1. That is, the y value for this x is equal to -1 whenever x is less than or equal to -1. So on this number line, where is my -1? So that is 0. On the left side, you have -1. From here, everything on the left hand side of this -1, the y values are also going to be -1. Let me put it in the form of a little chart here. X, y. You need at least 3 points to get a straight line. And okay, I'll start off with this condition x less than or equal to -1. So 1 is included. I mean, this -1 is included in this inequality. Like, you're saying less than or equal to -1. So when I mark that point on this graph, I have to make sure that I use a solid dot. We'll look at it just now. So first number, when x is equal to -1, the value of y is going to be -1 only. In fact, in all those, for all the x values satisfying this criteria, satisfying this particular condition, will have the same y values of -1. But only thing is, make sure that you are taking those x's which are less than or equal to -1. So now let us take one more x value. So after this -1, anything I can take. If I want, I can mark -2 or -3, -5 or -10 or -15, which is outside the graph. Anything you can use. But we take or we make use of the numbers which are convenient, not so big, not so small. So for that reason, I'll write x equal to -3. You know, -3 is on this side and it is less than -1. So that's good. One more point. If you want, you can take -5 or -6. That's fine. Okay, these are the 3 points we have. Let us plot them. The first point, -1, x value -1, y is also -1, and it is a solid dot. I'll use it here. This is my x1 and y -1. This point, we know. Now x value -3 and y is -1. So -1, 2, 3. It is -3 here. Y value -1. That's the dot you got. Now third one, x is -6. X value -6, and after -5, go by 1 unit. That's -6. When x is -6, y is -1. So 3 points are enough. I can draw my straight line. Joining them, let me draw. Okay. From this dot, connect, and it goes all the way, right? Because any number less than -1, so all the way you can go on extending it. Okay, so this is your arrow indicating that it is extended on the left hand side. Okay. Now our second piece is f of x is equal to 1. Again, just 1, we have a constant number. And the condition, x value is greater than -1 and x value is less than 1. So it is between -1 and +1. Those are the values I have to take. In fact, x equal to 0 is the only number, that integral number satisfying that. But in between those two numbers, there are so many decimal numbers. So we have to consider all those. That's the reason we will look at the boundaries -1 and +1 in our chart. Let us include them in our x, y. I look for at least 3 points. Out of those 3 points, the boundaries are important. So for x is equal to -1, I'll go ahead and write off 1. But the thing is, this -1 is not included. It is excluded from the value of x. We are looking for the number which is greater than -1. There is no equality. That's the reason I'll make a note that this is open. I have to draw an open circle. I don't put a solid dot like we did in this red ones here. We have to draw an open circle for this point. Now the second x value, let us have 0. When x is 0, y is again 1. For all those x values, the y is going to be 1 only. That's what it says here, provided the condition is satisfied. Now the third value, x is equal to 1. So y is again 1 only, this one. And this one is not included. That's why my graph, the dot, I have to make it open. That is open circle I'll draw. Okay. Let us plot these points now. -1, x -1 and y is +1. X value -1, so go up by 1. Y value +1 and it is a circle. Open circle, right. For 0, it's 1. When x value is 0, y is 1. No doubt it is a solid. It's in between and you have a solid there. Third, 1, 1, x value 1 and y value 1 and it is open circle. Right? And it is confined within this region, -1 to +1. So connect those two endpoints, the first dot and the last dots, by means of a straight line. So this is the graph of your second piece. F of x equal to 1 under this condition is that. That is the graph of this particular piece. Now let's go to the third case. Here f of x is equal to x where x is greater than 1. X is greater than 1 means any number after 1, like 2, 3, 4, anything after this one, everything. All the numbers on your right. You will consider from 1, you will go all the way. Okay, so the first one here in our table, I'll take x, y, 1, 2, 3. The boundary, the limit is 1, so let me take off x equal to 1. Okay, when x is 1, f of 1 is equal to 1. So the answer is 1. But 1 is not included in this graph. So therefore, I'll have to make a note that it is open. Now take one more point that is greater than 1. After 1 on this side, I can write 4. So f of 4, like here f of x equal x. Now f of 4 becomes 4. Whatever you have for x, the same thing will be there on the right hand side, 4 and 4. Then one more point, I'll take anything. You can take anything above 1, 2 to all the way, anything. So let me write 6 or 7 or whatever you want. Right, 7, 7 I have here. Okay. Let us locate on this graph. My first point is 1, 1, x value 1, y is also 1, and it is open circle, and already we have it there. Let us not go further, just I have an open circle, that's fine. Now 4, 4, x value 4 and y 4. This is 4, then I'll go up by 4, 1, 2, 3, 4. It's a solid because that point is included. 4 is greater than 1. One more point, I have 7, 7. I can even mark 7, 7 or 6. This is 6, 6. Next is 7. 1, 2, 3, 4, 5, 6, 7. Right. Now connect to them. I have this one, starting from your first dot, go all the way, and on the right hand side it is unlimited. You can go all the way. That's why we have an arrow there. This arrow indicates that it is unlimited. Go to infinite number of x values, you'll get the y values. So altogether you ended up with 3 graphs, 3 pieces from this piecewise function. The first, the second, and the third, right?